How's everyone? How was your weekend? How's your day? Testing 1, 2, 3. Hey, there we go. Awesome. Alrighty. Well, let's start with PA3. How's PA3 coming? Decision trees and nodes and ingest methods. Your audio is broken. Is anybody else having audio issues? Okay, because my Zoom has been like broken 100 different ways today. My trees feel weird without pointers to me. Yeah, isn't that funny? Okay, good. We get so busy with pointers in C, and we forget that they're like not actually like intrinsic. Baseline working, hopefully able to build off of it. Okay, that's good. So let's do one more pass over kind of a high level view of how we can set up PA3. And if you're already beyond this and you've got, you know, good progress working and so on, don't worry about this. But if you're stuck kind of on how to organize this, let's do another look at a possible big picture view of putting together this system. So let's think of a tree class. And the main thing the tree class is going to hold is the root. So there's going to be a root node. And it's useful, I think, if you put inside your tree class a method for reading in a database file. So we could have, you know, read database. And that takes in a file name. And what does it have to do? It has to, you know, make a scanner. So open up a scanner for reading in from that file name. You got to do the try catch business and all of that, right? And make sure that you succeed. And maybe you could make this, you know, return a Boolean to say whether it succeeded or failed. I don't think I asked you to handle that, but you know, if you try to open a scanner and you can't, you want to do something so you could return false or true if you like. But open up a scanner on the input file, and then let's call ingest. And here's the way I'm thinking of ingest. Ingest takes the scanner object, and whatever point you're at in the file, it begins at that point, and it reads until it's read a complete decision tree. And it builds that tree into memory, and it returns the root of that tree as a node. All right, now if you've just opened your file and your scanner is pointing at the first line of that file, and you say ingest, the return to ingest should be one big decision tree that's consumed the entire file. But if you're sitting somewhere inside that file and you call ingest, you know, you may be sitting at an answer node, in which case ingest would just return a tree containing a single node, which is that answer. But if you believe that, you know, ingest will do the proper thing, right, then what we can do in our read database function is just say root equals ingest. And that's your whole method for reading a database file. Open up the scanner, call ingest, whatever it returns, set root equal to that. And then we're left to make the ingest method. So this is going to definitely return a node. And this is that thing that we've been specking out in pseudocode. So, you know, so read a line from SC. So, you know, string temp equals SC dot next line. Don't use equal equal, right? Use dot equals. So if temp dot equals quote a colon, right? Meaning it's an answer node. Then let's make some temp node here. So if it reads an answer node, let's do something like temp dot q flag equals false. To say it's an answer instead of a question. Temp, whatever you call your string, can just be the next line of your scanner. So read the next line, set that to the data, and then set the children to null and return temp. So if you read one line from the file and it says a colon, you know you've got an answer coming. Set the answer flag to the question flag to false or the answer flag to true. Read the next line, save that as the text of the node. Set your children to null, return your node. Otherwise, it's a question. And so what do? Set the Q flag equal to true. Read the next line. Save that as the text of the node. So same thing we did up here. But in this case, the yes child comes from ingest. And the no child comes from ingest. And return that node. That's basically your ingest method. Okay, so why does this work? Well, if we believe that ingest does what we just said, which is starts at the current point in the file, reads until it's read an entire decision tree and returns the root of that tree. If we believe that's what ingest does here and here, then all of this is going to be correct. Right? It's recursion, it's mathematical induction. It's P of n and P of n plus 1 if you like. If you don't worry about it. But you know, assuming that these do the right thing, this whole thing will also do the right thing. And maybe our base case here is, you know, when we just have an answer node because there's no recursion there. So we have two kinds of nodes. Well, we have one node, you know, with a flag, but, you know, is it furry? Yes. It's a cat. No. Does it like dirt? And if yes, it's a worm. And if no, it's an ant, although I think ants like dirt too. So as you're playing the game, you're going to ask a question, you're going to move left or right. You need to know when to stop, right? You stop when you get to an answer node. So those are answers, these are questions. So when you have an answer node, there's no children. Technically, you're never going to travel down to the children, so you don't really have to do this, but you know, you want to make sure that you give values to everything, every object. And when you construct it, those will come out null anyway, but we're just kind of being explicit here. So you could put a comment there saying, you know, this is a leaf node, it has no children. All right, so why do we have a tree class, right? The node class is really just holding the data, the Q flag, the yes and no children, and also, you know, it's the node left-right traversal method and so on. But the nice thing about having a tree class is that in our main program, we can do the following. So set, you know, a string file name equal to something. So it's either 20q.txt or args bracket 0, right? But once you decide that, you can now say tree t equals new tree to construct an empty decision tree, and then you can say t dot read database and pass it the file name. And that will run all of this code, and when it's done ingesting, it will set the root of this tree equal to what ingest returned. And now you've got a decision tree ready to go, and if you want to play, you know, you can say t.playGame. And if you only wanted to play the game once and you weren't worried about updating maybe, there's your whole main program, right? And this is very, very kind of object-minded. When you're playing your game, you don't want to be thinking about ingest, you don't want to be thinking about nodes and yes children and no children and answer flags and all of that kind of stuff, right? Make a tree, read in the database, play the game. 3 steps. Extra step if you want to do some fiddling around to decide what file you're going to read the database from, right? But this keeps your interface from the main program to the tree class very clean. The tree class starts, you know, dealing with scanners and calling ingest methods and so on and so forth. Let's see, let me catch up on some chat questions. With this ingest method, what do you see PA3 main doing to kickstart everything? Just the basic, do you want to play and initialize the tree? Yeah, there we go. Okay, good. Let's see, will you be using our main or will you be using your own main? I'm going to use your main. Yeah, I'm just going to compile up your code and run it, and then eyeball it. How's everybody capturing the user input? I'm doing something like response equals SC next line, then using response equals ignore case Y to see if they answered Y or whatever. Curious if there's a better way. Got a variety of options here. So one thing is, keep in mind, you know, to read the user's inputs, yes, no, you know, I was actually thinking of a Wumpus. You need to have a scanner that's reading from system.in. So you're going to have 2 scanners in here, right? The one reading from system.in, you want to probably set up in main and, you know, maybe pass that to play game or whatever. The one that's reading from the database file, that's local to like the ingest method and maybe the read database method. Once you've used scanner to read in a string, what should we accept for yes or no? So I don't think I specify this in the assignment, but here's a way to be really nice to your users, right? If you could accept Y or yes or Y or yes or yeah or yeah or yeah, right? You could choose to accept any of those as a Y. And the key is the first character is an upper or lowercase y. And you could take no or n or no or nope or never or nada or no, or whatever, right? And just take the first character and see if it's an N. So yabba dabba do would be yes, which it is, right, in formal English. Um, so how could you do that? Well, if let's say you read your user response into a string called temp. So you could say temp dot to uppercase dot character at 0, and that's going to be a character, so we can use equal equal and see if it's equal to a Y. Yeah, and you could say not no or and yes for no. Be careful with this though. If your string has no characters in it, char at 0 will throw an exception. So, maybe throw a check in the beginning that, make sure the length is bigger than 0, right? So if it's this, you could say yes. If it's that, you could say no. Otherwise, you can say, hey, type in something that starts with a Y or an N. Or you can just, say if you don't say yes, I'm going to take it as no. That's not quite as user friendly, because if they mean to say yes and they accidentally hit a T, right, and you take it as a no. So yeah, your choice. Does empty cover that? I don't know the empty method. I've seen a number of people use that. Is empty returns true if and only if the length is 0. So yeah, you could do string.isEmpty. Or you could do string.length is bigger than 0. But what I really do not recommend, and you would definitely get frowny faces from your boss, is doing this in a try catch block to throw an exception if the string is empty. That's like really, really heavy-handed, right? Don't do that. Check first to see if the string has length 0. Or if you want to check explicitly, if you're only going to accept YES in lowercase, right, then it's just if temp dot equals yes. And that'll be true only if the input was exactly YES. And that's valid. And interestingly, you could just as well do this with the following statements. If yes dot equals temp. And that's totally legit. Why? Because quote yes is a string. Strings come with an equals method. And pass that method the thing you're comparing to. There's the classic try-catch block in chat. Good job. They should just put that in the kernel when you boot up. And then, like, if an exception ever occurs, it'll just go to a operating system catch block. Wait, I think that's what it does. Yep. Yeah, but do you believe him? Alright, let's see. If I missed anything else in chat, ping it again, because recursion confuses me. Yeah, recursion is confusing. And so the joke is the secret to understanding recursion is understanding recursion. And if that joke makes sense, then you're good to go. What is the base case for that? That's the problem. Yeah, so it might make more sense in Java, or it might be that you've had some time to sit with the idea. And it may be if you started in Java, it would kick in when you started doing it in C. I don't know. But if it's making more sense, that's good regardless. All right. Well, we are at week 5 right now, so just about halfway done with the course. Recursive banana. That sounds good. But do you get recursive banana bread if you make banana bread out of that? Recursive banana is not a bad band name either. So week 5, my plan for this point on forward is we're going to keep working in Eclipse, okay? We're going to play around for the next few days with some of the widgets and sort of dig a little deeper into the stuff we went through quickly last week. Looking at attributes of these things, connecting the code and the things we can do in Windowbuilder and how those things affect the appearance and behavior of these objects. And I want to go through labels and buttons and checkboxes and radio buttons and things like that. Probably tomorrow I want to step back and look at how we would do this from just a plain, sit at the command line, write this code in VI. What's sort of the minimum that we need to make this work? Because our code's going to get more and more complex, the more we tailor it and customize the appearance and so on. But it's useful to kind of know the bare minimum that you need to create a window and put some buttons and respond to events and so on. So we'll play around with that. That'll take us into a subject called inner classes and anonymous inner classes. So we'll talk about some of that stuff. And then I want to talk about JavaDoc, which is a way to really easily document your work and do the kind of documentation that I've been talking. And that'll take us up to PA4. I haven't fully decided what PA4 is yet, and I haven't made the PDF, so I can't let you look at it yet. But I'm thinking maybe on Wednesday I'll try to get that up, and maybe even start talking about it on Wednesday, even though you have till Friday for PA3. But give us a few days of class time before the weekend to look at PA4. PA4 is going to be an optional group project, so I will let people work in groups of up to 3 people each. From this section or the other section, so you can cross sections as you choose. And it will be some kind of game, and it will be built using Swing, and it'll be graphical in nature. And then PA5 will probably be a networked version of the game we come up with in PA4. So we'll talk about JavaDoc. We'll talk about doing painting for displaying things, doing graphics on a screen, and so on. And that will probably do us for talking about GUIs and Swing and Windowbuilder and so on. And then we've got to talk about threads and threading and resource contention, dining philosopher problem, all the things related to running multiple processes that are sharing resources. We'll talk about networking, which will be a lead-in for PA5. We'll talk about the URL class in Java. We'll build a web browser in class and talk about some details of that. And then there's also some more data structure stuff that I still want to go through. I'd like to go through Huffman coding, maybe go through red-black trees, which is a different kind of balanced tree, and I think somewhere through all of that we'll probably find out it's week 10. So we'll see how much of that we get through. But that's sort of a longer range view. I don't know if I'm going to do presentations for PA4 or just turn in. I don't know. Presentations are always tricky because they end up taking a lot of time. So I'm thinking I'll probably run the stuff myself, but it depends what the game is. And some people don't like presentations, but the more you practice, the better it gets usually. And Zoom is a better way to be doing presentations than in person if you're kind of uncomfortable with it. So it's potentially good practice. When you start Eclipse, would you do one more Hello World creation of a GUI swing project? Absolutely. I'm missing the GUI part of loading the swing components. Can be very short. Yeah, that's what I'm planning to do anyway, so that'll work out really well. Alright, so yeah, let's do Swing and Windowbuilder. So Eclipse was crashing fairly frequently this morning, so I'm going to keep this window open so I can restart in a hurry. Alright, so let's start from scratch here. So I'm going to say File, New, Java Project. And what should we call this? Let's call it Monday afternoon, because that would also be a good first hit for recursive bananas. Alright, so I've created a new project. All these other projects are closed, right? There's no little arrow next to them, so I only have one project open. Okay, so let's go File, New, and you come down to Other, and then scroll down to Windowbuilder, open that up, scroll down to Swing Designer, open that up, and then do JFrame. So that's the whole chain. Or just search for JFrame, but alright, and then name, so you can call this whatever you want. So we'll call this Basil Control. Oh, Basic Control. Call it Basil Control, because my basil plant is doing so well. Alright, and there we go. There's our whole project. So I'm just going to run this. I'm going to do a Control R to run, and there's my basil control. Yeah, I think my brain is more used to typing basic than basil. Alright, so I can terminate this by hitting the X, and there we go. But hey, it's topical. Check this out. Bam. So this was like one tiny little strand of brown stick with a couple of basil leaves on it. And did some Googling. And found out basil, not only do you have to be careful about how you water it, but you need to keep pruning it. So I like pinched off the tops and put them in water, and it just keeps growing now. And when it gets taller than about that much, I pinch off the top, put it in water, let it sprout some roots, plant it back in the dirt. And so I got lots of basil now. Can't bring myself to eat it though, because it was like such a effort to grow it. All right, so there's our basil control, right? So basic frame. And we can go in the design window, right? And remember, this is a visual view of that code. And so we can drag and drop components, and as we do that, it will write code for us, or we can write code, and when we come here, we'll see the effect of it. So let's start off with we're looking at this layout manager business. So a J label is about the simplest component we have. It's really just a box that's going to hold some text. We don't tend to interact with it too much. It's really just kind of a placeholder. But if I click this and I come in here, I get this sort of like north, south, west, east, center view. And so, I don't know, I can put my label there, and I can put another label up here, and I can put another label down here. All right. And if I run this, what do I get? I get something that looks like this. And it's set up so that if I change the size of the window, right, it keeps my labels equally spaced. They're all sitting on the left. And so that can be useful, but that may not be what I want. It may be that I wanted these two labels to be next to each other. So I can try to move this up here. Well, it's not going to let me do that. I could put it over here and then run it. And now I've got something like that. But again, right, as I change the size of the window, it will keep, you know, this label flush against the right and the other label on the left, and that top left one in the top left corner, and so on. So there's a window manager that is responding every time the window changes size or shape and potentially repositioning these objects. And so I can put, you know, a different window manager inside one of these areas and start tiling things up. So all of these things, these layouts, these are different ways that you can organize your widgets on the screen. And what I'm going to do is I'm just going to change this to an absolute layout, which I knew was going to crash Eclipse, because on a good day that's a sketchy thing to do. But you know, I saved my window back there for quick access. All right, so what do we got here? I'm going to try it again because I'm just curious if this will crash again. Hey, okay. Alright, so I've got some labels. I've got a label there. Alright, I'm going to delete these. So let's put our labels in here now. So I'm going to take one label and I'm going to put it right here. And take another label and put it right here. And I'll put a third label, I don't know, like right here. Alright, so now if I run this, right, that's exactly what I got. My labels are right there where I put them. So I have precise placement control over this, but, you know, if my window changes shape, those things are still just kind of sitting up there in the corner instead of taking advantage of this extra space. Or if I do this, you know, one of my labels disappears. And if I use a layout manager, then it might move this, you know, over here and bring this one down and so on and so forth. So it's stylistic choices, right? For what we're doing, I strongly recommend just using the absolute layout manager. Place your components and just don't plan on the window being resized. Give it an initial size that works for whatever you're trying to do. So you can go to your J-frame and you know, maybe I want a 703 by 520 frame. Hello. Let's try that again. I think it's crasher clock. Okay, there we go. Yeah, or make it 4K to begin with and pity the user. Right, so there's what it looks like. So pick a size that works for you and just use an absolute layout manager. That's going to work really well. And you're going to want to design your interface, right, on paper probably before you code it up or before you get too deep into this. So we don't have to worry about fancy layout managers for now. And so the layout manager is basically coming down here when it says set layout null. Null is saying you just use absolute layout. All right, so let's play with one of these labels. Let me get rid of two of these. Let's just put one of them in here. And we'll go back to a reasonable sized window. Alright, so what can we do? Obviously we can change the text. So I can change the text to say hello. And when you do that, what happens in your code? Well, the constructor for this label passes an argument, which is a string. And if I change that string, right, then when I look at the visual representation, and I crash Eclipse, we'll see that new label. So the view you're seeing in Windowbuilder and the code that's written in Java, they're related to each other. This is an annoying new wrinkle. It doesn't want to like open that up automatically. So if it does this to you, right, it's telling me that this file does not exist, which it does. I'm just going to close out the tab and then come down here through source and open it up again by double clicking. And that seems to work. So there's our label with the new text in it. Yeah. Alright, so we can change the text. We can change other things. So the foreground color is showing up as 51, 51, 51. And we can change this to something else. For example, we could change it to red by clicking on red. And now the text is red. Alright, so what did that do to our source code? It added a new line of text that said, label new label dot set foreground color color dot red. Alright, so let's decode this alphabet soup. First of all, the variable says what the name of this object is, label new label. I'm going to change that. So what should we call our label box? Let me just call it lab1. So this is called lab1 now. Sorry, this is called lab1. And if I look at the source code, right, lab1 is a J label. It's equal to new J label, goodbye. And then it says lab1 set foreground, lab1 set bounds, content pane add lab1. Alright, so what is this? Color.red. Well, if I did color.green, what do we think's gonna happen? Hey, magic, right? My font is a pukey green. So what is this color business? Well, like everything else, color is a class. Right? There's a class named color, and it has a number of static fields, including a field called green and a field called red, and also a field called lowercase red. Okay, so a static field, remember what that means. It's a class field. It means that we can get to this field by using the name of the class itself, right? Which is uppercase color in this case, period, and then the name of the field. Yeah, those are fantastic descriptions, right? This is like, you know, an A+ from the teacher. So we can do this kind of thing, color.green, right? That's saying go into the class color as opposed to an object of type color. Go into the class and access this field called green, which represents the color green. But there are other ways we can do this. So we can construct with one of these colors. But we can also construct with a set of 3 integers. So R, G, and B, and these specify the intensity of red, green, and blue in the range 0 to 255. And this is probably the oldest and perhaps the most common way to specify a color. So let's think about this for a minute. So when you mix paint, you have 3 primary colors, right? Red, yellow, and blue. When you mix light, you have 3 primary colors. which are red, green, and blue. And for pigment, the green changes to yellow. With pigment, if you mix a bunch of colors together, you get black. With white, if you mix a bunch of colors together, you get white. Yeah, alpha is better. Yeah, and then magenta, yellow, cyan, because it's all about the ink. All right, so each of these we can specify an intensity of, and typically the value you see most often is from 0 to 255. Why 0 to 255? What's the significance of that? Yeah, so 2 to the 8th. So these are all the values you can specify with 8 bits, which means each of these can be specified with an 8-bit value. So typically, to specify a single color, 24 bits. So 8 bits for red, 8 for green, 8 for blue. Together that specifies a particular color. And so when you see, 16 million colors, that's what it's talking about. There's 16 million possible combinations of these. Can your eye discriminate those? Can your monitor display those? It depends. But if we set up our color like this, right, then we've got 256 values for each of these. And if we break these into half bytes, right, nibbles, it's 6 hex characters. So for example, FF0000, that would be red. So this corresponds to the red piece, this corresponds to the green piece, this corresponds to the blue piece. When you have FF, that's white. If you have FFFF00, that's red and green, that's going to give you yellow. And I'm using FF to put in 255, but if I wanted, faint yellow, I could do hex 808000. Or I could pump up a little bit of blue in there by putting something non-zero down there. So yeah, 16 million possible colors. And so we can specify a color in that way. So we could say new color, and I don't know, let's do 250 red and 120 green and 60 blue. And so this is going to be mostly red, green, so yellowish, something like that. All right, and there's other ways you can do this. You can specify this with floating point numbers from 0 to 1 for red, green, blue. You can specify an alpha value, which is kind of like an intensity for the whole thing, and so on. And you can use various methods on here. So we could say brighter, and if you have a color and you call brighter, you get a brighter version of it. So it, scales up the intensity of red, green, and blue. Or darker, or you can see if, one color is equal to another, or you can get the intensity of the individual channels, get blue, get green, and so on. And so it's a whole class with, a whole bunch of objects, a whole bunch of methods and fields associated with it, right? And we may never need to worry about that in here because, if we want to set the foreground color, we can always just come in here and say, yeah, let's make it cyan. And there you go, you're done. Come on. Do I have to save it? I think I did that on the wrong object. There we go. All right. So we can set the background color. So let's make the background really bright red. And we're not going to notice that, right? Because it's not actually setting the gray part of this label. But for example, if we turn on more properties, we can go to border. And we can say, let's put a border on this. Let's put a beveled border. So I'll come up here and I'll say bevel. And I can change, you know, the colors and so on. But if I do that, I've got something like this, right? So it looks kind of like three-dimensional. And so you can spend, you know, your entire time that you have to work on a project just messing around with these properties of objects, right? This is just a label. It's a really basic object, but we can set up all these things and experiment with it. We can obviously control where it's placed. So the set bound specifies the position and the dimensions of this. So if I change this to, you know, 400 and 500, oh, come on, man. Oh, my bad. Label. Alright, 200, 300 on the label, so the label moves down, out of sight. Come on. If it was Friday, I'd say it's Friday, but it's not. Eclipse is having a Mondays. No, that north, south, west, east, center is the default layout. There's our label, 200 across and 300 down. So if you want an absolute layout, you have to click absolute layout and then click inside here to set that up. All right, so and you can do some tinkering of this, you know, from code. So I can get rid of the colors and come back here, and it'll go back to black text and so on. All right. Wow, it's like almost time up. That went fast. All right, so let's start digging into more of these widgets tomorrow. I want to look at the different actions that we can do on them, and give you an idea of the scope of that, because we can pick up very, very detailed actions. For example, if somebody hits the shift key while their mouse is sitting over an object, we can detect that, even if they don't actually hit a character with it. If they press down the control key or the Windows key, we can pick that up, and we can choose to respond to it how we like. And you may not need to do this for, you know, your projects, but I want you to get a feel for the kinds of things that we have access to and control over, and then you can pick and choose what you want to use. All right. There's a default to not pick it up unless we register for the event. Yeah, so by default, there's no events handled except on the frame itself. So the main frame will respond to things like resizing by, you know, drawing a bigger frame, and the panel will increase and so on. But these don't do anything. Buttons won't do anything. Checkboxes, I think, will check and uncheck, but they won't cause any actions to occur. And so we have to register events for those. So we'll do that tomorrow also. All right, we are out of time. So so have a good afternoon. I will see you tomorrow.